Industrial remote maintenance demands minimal latency and jitter, a requirement often failed by legacy IPsec or OpenVPN due to excessive overhead. WireGuard operates efficiently in the Linux kernel space, utilizing the modern Cha-Cha-20 and Poly 1305 cryptographic primitives. This combination ensures high throughput and low resource consumption, critical when tunneling supervisory control and data acquisition protocols across wide area networks. We are deploying the server component on a Debian gateway, which bridges the public internet to the internal operational technology network. Verify the WireGuard kernel module is loaded using the command lsmod pipe grep WireGuard. If the module is missing, ensure your kernel version is 5.6 or newer, or install the appropriate backports package. The foundation of the WireGuard setup is asymmetric cryptography. We must generate a unique private and public key pair for the server. Execute the command wg genkey pipe t private key pipe wg pub key greater than public key. The private key file must be secured and never shared. The public key is used to identify the server to all connecting clients. Install the necessary tools using apt install WireGuard tools. The server configuration file will reside at the standard location /etc/wireguard/wg0.conf. Ensure this file has restrictive permissions, typically 600, preventing unauthorized reading of the private key. Inside the wg0.conf file, define the interface section. Start with the private key reference. Private key equals path/2/private key. Assign the internal tunnel IP address for the server. For example, address equals 10.10.10.1/24. This address space is dedicated solely to the VPN tunnel. Define the listening port. Typically, listen port equals 51820. This port must be accessible from the public internet. Crucially, enable IP forwarding permanently by editing /etc/sysctl.conf and setting net.ipv4.ip_forward equals 1. Apply the change immediately using sysctl --p.
The server must perform network address translation to route client traffic from the tunnel into the industrial network. We use iptables for masquerading. In the wg0.conf interface section, add the postup command. Postup equals iptables -a -forward -i wg0 -j -accept. iptables -t net -a post routing -o eth0 -j masquerade. Replace eth0 with your server's external network interface name. The corresponding predown command must flush these rules. Predown equals iptables -d forward -i wg0 -j accept. iptables -t nat -a post routing -o eth0 -j masquerade. Each system analyst client requires its own unique key pair. On the client machine, repeat the key generation process. wg genkey pipe t client_private key pipe wg pub key greater than client_public key. The client private key is used in the client configuration file, for example, remote_analyst.conf. The client public key must be securely transmitted to the server administrator for peer registration. Never reuse key pairs across different clients or servers. Key management is paramount for maintaining the integrity of the remote access solution. Return to the server's wg0.conf file to register the client as a peer. Create a new section, --peer, Paste the client's public key under public key equals client public key string. Define the specific tunnel IP address assigned to this client using AllowedIPs equals 10.10.10.2/32. This /32 mask ensures that only this single IP address is routed through this specific peer tunnel. For additional clients, repeat this peer section, incrementing the tunnel IP address. Apply the configuration changes by restarting the service. wg-quick -down wg0 wg-quick -up wg0.
The client configuration file, remote_analyst.conf, contains two main sections. The interface section holds the client's private key and its assigned tunnel IP address, 10.10.10.2/24. The peer section points back to the server. Use the server's public key here. Define the server's external address and port using endpoint equals server public IP colon 51820. The AllowedIPs setting determines which traffic is routed through the tunnel. For split tunneling, specify the industrial network subnet. For example, AllowedIPs equals 192.168.50.0/24. This ensures only traffic destined for the operational technology network uses the VPN. Activate the client tunnel using the command wg-quick up remote_analyst.conf. Immediately verify the connection status on both the client and the server using wg-show wg0. Look specifically for the latest handshake field. A recent timestamp confirms successful key exchange and connectivity. If the handshake is 0, check the server's public firewall rules and the listen port setting. Test end-to-end connectivity by pinging the server's tunnel IP, 10.10.10.1, and then a target device on the industrial network, such as a programmable logic controller at 192.168.50.10. Successful ping confirms routing via network address translation is functional. To prevent connection drops caused by network address translation devices timing out idle sessions, implement PersistentKeepalive on the client side. Add PersistentKeepalive equals 25 to the client's peer section. This sends a small encrypted packet every 25 seconds, maintaining the tunnel state. For enhanced security, consider using a pre-shared key in addition to the public key cryptography, providing protection against future quantum computing threats. Finally, restrict access to the server's public port 51820 using external firewall rules, allowing connections only from known static client source IP addresses.